Hey y'all, welcome back. In this video, we're going to go over the third practice test that I put together for my college prep math students studying for the TSIA2, particularly the math section. So we're going to go through each of these 20 questions and talk about how you worked them all. If you've already done the first two practice tests, you're going to see that some of these questions are going to feel a little familiar. They're really just variations on a lot of the same problems, although there's a couple new ones on here. So as with the other tests, the best way to take advantage of this video is to download the practice test PDF that I've got linked in the description. Try to do as many of these questions as you can. Your goal or your target should be to try to get 12 out of the 20 questions correct. And whether or not you do that, once you're done, come back to this video, and you don't need to watch necessarily the whole thing, but go through the ones that you got wrong, or even if you got one right but you just kind of guessed on it, and sit through the explanation so that you have a better idea of how you can get this question right in the future. And then once you've kind of gone through and corrected all the problems you've done wrong, try to take the test again and see if you hopefully you'll see an improvement in your performance. So let's go ahead and just start diving into these questions. Number one says a certain map has a scale in which 1/4 inch on a map represents an actual distance of 5 miles. So we have a relationship here between inches and miles for the scale factor on this map. And so we want to set up a proportion here. And we're going to say that 1/4 inch in the context of this problem is going to be equal to an actual distance of 5 miles. And we want to know if there are X miles, how many inches are there? Now, this is a little bit tricky. This problem's a little tricky because you're not actually trying to find for X. You're trying to or solve for X. Instead, you're trying to find the number of inches on the map that would be represented in terms of X miles. So there's not a variable given for what you're actually trying to find here. I'm just going to put a little question mark and put that in a little box as a reminder to us that that is what we're solving for. So the way we're actually going to solve this is by using the cross products property and cross multiplying the numerators and denominators of this proportion. So we'll multiply 1/4 times X and 5 times that question mark. So 5 times that unknown number of inches is equal to 1/4 times X. And then to solve this equation for the question mark, which is what we're actually trying to isolate here, we'll divide both sides by 5. Now this is a computation you probably want to do in the calculator here, especially because we're dividing fractions, and that can get a little tricky there. But 1/4 divided by 5 is 1/20. So we have the question mark box is equal to 1/20 X, which is also equal to X over 20. So the correct answer here is A. Number 2 says Jessica bought 5 binders, Daniel bought 4 binders, and an $18 ream of paper. Together, they spent $58.50. If each binder cost the same amount, how much did each binder cost? So we're purchasing 5 binders for Jessica, 4 binders for Daniel, and then just a single $18 ream of paper. The total amount is $58.50. Once you set up this equation, it might be easier to simply plug in these potential answer choices into X and just calculate using your calculator what this expression equals. Like for instance, 5 times 3 plus 4 times 3 plus 18. And if that does equal 58.50, then you know you've got it right. So you can test each of the answer choices if you feel a little shaky on your algebra, but let's actually go through the algebra so you can see how it's solved properly. 4x plus 5x is going to be 9x because we're buying a total of 9 binders. And then we've got a 2-step equation here, and the first step is going to be to subtract 18 from both sides. That'll leave me with 9x equals $40.50. And then kind of running out of room here, so I'll continue this up here, 9x equals 40, 50. To get the x by itself, we want to divide both sides by 9. So this is a computation you're going to want to do in the calculator once again. In fact, really any arithmetic that you have to do, as long as you are allowed to use the calculator on that problem, I would say go ahead and do it just to save yourself the the stress of getting some basic addition, subtraction, multiplication, division incorrect. So anyway, we divide this by 9, and we're going to get 4.5. So the binders are each going to cost $4.50, which is answer choice C. Number 3 says Ralph traveled 13.6 miles in 2.4 hours. At this same rate, which of the following is closer to the time it will take him to travel 30 miles? So this is going to be another proportion problem where we're relating miles to hours. So 13.6 miles is to 2.4 hours. We want to use that ratio to find the number of hours it's going to take him to travel 30 miles. Now, when you're setting up this proportion, kind of like how we did in number 1, it doesn't really matter which unit you put in the numerator or the denominator. Like, I could have put the hours up here and the miles down here. But if you're going to do that, then you'll have to switch the other fraction as well. So basically, it doesn't matter what goes on top and what goes on bottom as long as you're consistent in both fractions. So if I started with the first fraction in hours over miles, then I would need to make sure that this second fraction was hours over miles. So they just have to be the same. Once you have it set up, we can use the cross products property like we did in problem number 1 and multiply across here. We'll have 2.4 times 30 equals 13.6 times x. 2.4 times 30 is 72. And then we need to divide both sides by 13.6. I don't think this division is going to work out very nicely, but we're just trying to estimate anyway. So this is going to be approximate. 72 divided by 13.6 is roughly 5.3. So looking at our answer choices here, the correct answer is going to be C. Number 4 says Zelda has 8 bushels of granola. She wants to pour all the granola into boxes that each hold 1 peck. So basically 1 box is going to be the same as 1 peck here. How many boxes will she need? So we'll start with the conversion that's given, and pecks and bushels, this is something we've talked about before, are pretty uncommon units of measurement. And I would fully expect that if they give you a problem with pecks and bushels, they'll also give you the conversion. I highly, highly doubt that they would not give you that. So 4 pecks is to 1 bushel, as how many pecks is to 8 bushels. Now, you could solve this using cross products like we did in number 3 and in number 1, but you could also just identify the scale factor here. You can see, like with the denominators, I'm just multiplying by 8. So if I do that with the numerators, 4 times 8 is going to be 32, and that's our answer. So you can kind of shortcut your way through this if you can easily see what the scale factor is. Now, that's not always going to be easy. Like in number 1, it was like in terms of x, so I wouldn't try to do it that way because 5 times what is x? Not very clear. Down here, 13.6 times what is 30? Again, that scale factor is not obvious. But if you're going from 1 to 8, the scale factor is pretty easy to come up with. Now, if you approach this like we did on 1 and 3, then you may have solved this using the cross products property. And so let's work through that algebra just so you can kind of see the answer for sure is 32. We would have 1 times x equals 4 times 8. And yeah, we'd get 32 either way. Number 5 says Pat bought 11 fruits from a farm. Apples cost $3 each, and oranges cost $4 each. If they paid a total of $37 for the fruit, how many apples did they buy? Well, if we know that there's a total of 11 fruits, then if these answer choices are the number of apples that Pat bought, then we can say how many oranges Pat bought, because there's a total of 11. So if Pat bought 4 apples, 11 minus 4 would be 7 oranges. If Pat bought 5 apples, then Pat must have bought 6 oranges. If there were 6 apples purchased, there'd have to be, not 7, but 5 oranges. And if 7 apples were purchased, then there'd be 4 oranges. So these are our 4 answer choices. And if apples cost $3, so I'll say A times 3, plus oranges cost $4. My first reaction here is to do 4 times O, but O kind of looks like a 0. So instead of O, I'm going to use R for oranges, because I don't really like using O as a variable. And the total is $37. So what I would do is just kind of go through each of these answer choices, A, B, C, and D, and plug in the numbers that are given and see which one gives you a total cost of $37. And then you should have a high degree of confidence that you got this question right. So for answer choice A, there are 4 apples and 7 oranges. So we're going to do 4 times 3 plus 4 times 7. So 4 times 3 is 12. 4 times 7 is 28. So 12 plus 28 is 40. And I would use that, you just use your calculator to do that computation. So that's not going to be right. What we're looking for here is 37. So let's try the next answer choice. And really, all of these are going to have the same setup. It's going to be 3 times the number of apples plus 4 times the number of oranges for each one of these answer choices. So I'm just going to set all of these up so that all I have to do is plug in the numbers for that answer choice. For part B, there are 5 apples and 6 oranges. For answer choice C, there are 6 apples and 5 oranges. And for answer choice D, there are 7 apples and 4 oranges. And so we're just going to use the calculator and compute all of these, compute the price for all these different combinations. 3 times 5 plus 4 times 6 is 39. So that's not going to be our answer. 3 times 6 plus 4 times 5 is 38. That's not going to be right. So it's looking like it's going to be answer choice D, but let's throw it in the calculator just to make sure. 21 and 16 does add up to 37. So our answer is choice D. All right, there's 5 questions from the quantitative reasoning section. Now let's take a look at the algebraic reasoning section. This is going to be a collection of problems that go over the concepts that you learn in an Algebra 1 class. So most of this is like solving equations or factoring quadratics. So let's go through a few of these. Number 6 says if x equals 2y and x plus y is 12, then what is x? Well, if x is 2y, then we can substitute 2y into x and rewrite this as 2y plus y equals 12. Combining my like terms will give me 3y equals 12. And then dividing both sides by 3 will give me y equals 4. So this is what y is, but they're asking for x. So if x is 2 times y, then if y is 4, x, which is 2 times y, would be 8. So the answer is C. For number 7, we've got a 2-step linear equation here. 4x plus 1 equals 12, and we're solving for x. So first, we'll subtract 1 from both sides of the equation. 4x equals 11. Then we'll divide both sides by 4, and that doesn't divide evenly, but the answer choices are all given as fractions, so you don't have to worry about converting that to a decimal or anything. The answer is choice C. Number 8 says factor the trinomial. So to factor a trinomial, you're going to be looking at the final term, and you're going to try to find numbers that multiply to give you this one and add up to give you this one. But before we come up with those numbers, I want to give you a different strategy that you can use for problems 8, 9, and 10, and really that you can use on any problem where you're just trying to compare an expression in the problem to the answer choices. So if it ever says like which of the following is equivalent, or what is equal to this, or what is this expression the same as, anything like that, we can use this strategy that I'm about to show you. And I'm going to use this strategy for all three of these, even though there are different algebraic ways of answering all these questions. This strategy can be used on any question where you're trying to compare two expressions. So here's what the idea is. Basically, you're going to, and I'll just spell it out here, we're going to pick a number for x. Okay, pick a number that's small and easy to calculate. I'm going to just go with 1. Okay, so I'm going to say x equals 1 is a good starting place. And it's possible that we might have to pick a different one. If that comes up on any of these problems, I'll talk about it, or what to do in that case. But for the most part, this should work. Okay, so then you're going to plug in your number and evaluate the question. Okay, so if I plug in x equals 1 into here and here, that's going to be 1 squared minus 3 times 1 minus 10. Now, this is something you'd probably want to put in the calculator just to make sure you don't mess up the arithmetic. But 1 squared minus 3 times 1 minus 10 is negative 12. Okay, so that's step 2. Step 3 is to check, oops, can't spell there, check each answer choice using the same x value. So in my case, I'm still going to use x equals 1, and I'm just going to substitute that in everywhere where I see x for each one of these answer choices, and then use the calculator to evaluate. And the one that equals negative 12, which is what I got for the original problem, that's going to be the answer. Now, if you master this strategy, you never have to do any of these factoring problems. You can just plug in your numbers and figure out what it equals. And you can even use this strategy for other types of problems where the basic question is like, what expression is the same as the one that's given? So let's run through each of these and see what it equals. So for A, we've got 1 minus 5, which is negative 4. 1 plus 2 is 3. And negative 4 times 3 is negative 12. So it's looking like could be A, but let's check the rest. For the next one, we'd have 1 plus 5 is 6. 1 plus 2 is 3. 6 times 3 is 18, so that's definitely not going to be right. 1 minus 5 is negative 4. 1 minus 2 is negative 1. So negative 4 times negative 1 is 4. It's not going to be C. And finally, 1 plus 5 is 6. 1 minus 2 is negative 1. And 6 times negative 1 is negative 6. The only possible answer here is A. Now, if you come across a scenario where you use this strategy, but let's say like 2 of these were equal to negative 12, let's just say like maybe this one was negative 12 and so was this one. If that's the case, you're just going to run the strategy again, but just pick a different number. Because sometimes if you pick a number that's like too small and simple, you'll get multiple answer choices equaling the same thing. But then just go back and pick a different one. So like if 1 doesn't work to narrow down the answer choice, try x equals 2 or x equals 3. Or basically just keep picking different numbers until you can narrow down what the correct answer is. X equals 1 is usually a good one, and we'll work for most of these. We'll see if we have to choose anything different on 9 or 10. But I'm going to use the same strategy here. So like with number 9, I'm going to plug in 1 into every instance of x. So 2 times 1 squared would just be 2, okay, plus 5 times 1 is 5. So 2 plus 5 minus 12 is negative 5. So what I'm looking for is if I plug in 1 into all of these x's, I get negative 5. So 1 minus 6 is negative 5. times 2 plus 2 is 4, and negative 5 times 4 is negative 20. So that's not exactly what we want, so we're going to say that it's not A. For part B, or letter B, 1 minus 3 is negative 2, 2 plus 4 is 6, and negative 2 times 6 is negative 12. Again, not what we're looking for here. We're looking for negative 5. Choice C, 1 plus 2 is 3, and 3 times negative 4 is going to be negative 12 again. So still not, we don't have the right answer. It looks like it's probably going to be D, but let's verify this. 1 plus 4 is 5, and 2 minus 3 is negative 1, and sure enough, 5 times negative 1 is negative 5. So that checks out. Our answer is D. Lastly, I'm going to use this strategy one last time here on number 10. I'm going to plug in 1. So 1 cubed minus 8 times 1 would be 1 minus 8 is negative 7. So that's the number I'm looking for. That's our magic number here for number 10. So let's plug in 1 everywhere we see x. See if we can't narrow this down. So A would be 1 minus 8 is negative 7. And then 1 minus 1 is 0. So anything times 0 is 0. So it's not going to be A. Letter B says, let's see. So we've got negative 7, 1 minus 8 there. And then 1 plus 1 is 2. So negative 7 times 2 is negative 14. No, that's not going to work. For this one, we've got 1 times 1 minus 8, which is negative 7. So that is negative 7. Looking like that is a potentially correct answer. But let's check this last one. This last one, what happens is we get 1 times negative 7 again. Okay, so I'm kind of glad this happened because I want to show you like how you can get this right when you run into the scenario where you get two answer choices giving you the same number. So if that happens, then we've narrowed it down. It's got to be either C or D. But what we need to do is pick a different number if necessary. So I'll add that as my fourth step. If you need to continue to narrow it down, further, just pick a different x value. Okay, so I'm going to use x equals 2, and hopefully we can figure out what our correct answer here is. So if I use 2, I got 2 cubed minus 8 times 2. This is something I'll throw into the calculator. 2 cubed is 8, minus 8 times 2 is 16. So 2 cubed minus 8 times 2 is negative 8. Now, I don't need to check A or B. I've already eliminated those as possibilities. So it's either going to be C or D. So let's check those. So for C, it's going to be 2 times 2 squared minus 8. Let's see, 2 times 2 squared minus 8 is going to be negative 8. So looking like C, probably going to be right. Now, if this happens again where we get the same thing again, we're just going to have to pick a different x value. But usually you don't have to do this more than twice. For this last one, we've got 2 squared times 2 minus 8. 2 squared is 4 times negative 6 is going to be negative 24. So that's not right. So for sure, our answer is C, not D. Okay, that's enough algebra for today, or on this practice test. Let's move into the area of geometry. Number 11 says, if the length of a rectangle, so we're talking about length here, is 17 less than, now the 17 less than, anytime you see the less than, that's kind of the hardest one to make sure you get right. But if you have if I have $10 and you have 3 less than me, you have $7 because 10 minus 3 is 7. So if I have 17 less than something, it's like whatever that something is, the length is going to be something minus 17. Okay, so what is it 17 less than? It's 17 less than twice the width of W, so 2 times W. And that's it. That's all this question is really asking for. Our answer choice is B. So really the only tricky thing to keep in mind here is the whole less than phrase. That's really the only operation that's going to be written in sort of the reverse order that you would write it algebraically. Number 12 says the formula for the perimeter of a rectangle with a length L and width W is given below. We can see that here. If a rectangle has a perimeter of 42, what could be the length and width? So if the perimeter is 42, and that's twice the sum of the length and the width, then that means the length and the width must have a sum of 21, because 21 times 2 is 42. So that length plus width has to add up to 21. So really all you have to do on this one is go through your answer choices and figure out which of these combinations add up to 21. So 10 plus 32 is definitely not 21, right? That'd be 42. 21 plus 21, well, that's definitely not 21. That'd be 42. 12 and 13, that would be 25, not 21. And then 14 plus 7, that does equal 21. So our answer is choice D. Number 13 says if a triangle has sides of length x, x plus 2, and x minus 1, what is the perimeter of the triangle in terms of x? So with all these triangle problems, I think it's a good idea to sketch it out. No matter what you're really doing with it, just having that visual can really kind of help you understand what you're doing here. Perimeter, you do need to know what this means. Perimeter is the distance around the shape. So to find the perimeter, you simply just add all the sides. So the sides here would be x, x plus 2, and x minus 1. We need to add those three together. And so when I add those, I need to combine my like terms. I have x plus x is 3x. And then I've got 2 minus 1 is just 1. So our answer is 3x plus 1, which is C. Number 14 says, what is the area of a square that has a perimeter of 32 feet? Again, and this is just kind of like the case for most of these geometry problems, usually a good idea to just draw it out. So we have a square where all the side lengths are the same and the perimeter is 32. Well, if all the side lengths are the same, we can divide 32 by 4 to get 8, and 8 will be the side lengths. Now this question is asking for the area, and the area is base times height for any rectangle. And for a square specifically, since the base and height are the same, we can just square the side length. That's actually why you say that's where the term squared even comes from, right? So anyway, 8 times 8 is going to be 64. So our answer is choice D. Maybe I should write that out here. 8 times 8, which is 64. Number 15 says if figure 2, so here's figure 2, is a 90 degrees clockwise rotation of figure 1, and here's figure 1, which of the following angles in figure 2 corresponds to angle C in figure 1? So when we do a 90 degrees clockwise rotation, so let's say like, let's see, what's the best way to communicate this? So let's start with D. Let's start with the side AD here. So if this side is like looking like this, if I do a 90 degrees clockwise rotation, then 90 degrees is a quarter of a revolution. That's like this much rotation. So this side is going to end up here. This side that I'm going to sketch in blue right here is going to end up like right here. Okay, the side that I'm sketching in purple here will end up here. And then the last side, I guess I'll do yellow here, will end up here. So the whole shape gets rotated, and that angle C, you can see, which is bordered by like the yellow and the purple sides, ends up over here. So when you do that 90 degree clockwise rotation, angle C is going to end up in the same place as where angle X is in figure 2. So So our answer choice, the correct answer choice for number 15 is going to be B. The last section is all about probability and statistics. So let's just run through these last 5 problems here. Number 16 says the average of 9, 17, and x is 12. So the way we calculate average is we add up all 3 of these values and then divide by however many there are. In this case, 3. But if they gave me like 5 values, then I would add them all up and divide by 5. And it says the average is 12. So this is our setup. And it might be easier just to go through the answer choices and substitute them in to see which one works. And so what I mean by that is take 6, plug it into here, and use your calculator to add and divide to see if it equals 12. And do that with all the answer choices, and you can reasonably come up with the correct answer. Now, you don't necessarily have to go through each of the answer choices and test them. You can solve this a little bit more traditionally, and the way you would do that is first you'd multiply both sides by 3, and that would give you 9 plus 17 plus x equals 36. Then combine your like terms here. 9 plus 17 is 26. So we have 26 plus x equals 36, and my last step is going to be to subtract 26 from both sides, and I get x equals 10. But if you feel a little uncomfortable with the algebra, don't be afraid to take advantage of the fact that this is a multiple choice test and test each answer choice into this little average equation here. Now, you still, at the end of the day, need to know what average means so that you could set it up to begin with. But if you can set it up, then either do the algebra if you can, or if you're worried about making a mistake on the algebra, you can always just test each of the answer choices and see which one works. Number 17 says students in Mrs. Gonzalez's class use rulers to measure the length in centimeters of a string. And each of the students got a different measurement. Okay, one got 7.5, one got 7.6, 7.2, 7.4, 7.9. And the question's asking which of these measurements would best estimate the true length of the string. And there's no real arithmetic, or you don't really need to do any mathematics in the traditional sense here. You just need to know what all these words mean. So minimum is the smallest value. And I don't think whoever happened to get the smallest value, they are most likely not going to be closest to the true length of the string. I don't think it's going to be the minimum. Similarly, the maximum, which is the largest value, there's going to always be someone who gets the largest measurement, but that doesn't necessarily mean that's the best measurement. So it's not going to be the maximum. The mode is the most common number in the list. And if we look at this list of values, there are no repeated measurements. So there's actually no mode in this problem anyway. So it definitely cannot be C. And even if it was, that's probably not going to be the best estimate. The best estimate is the mean, which is another way of saying average. And we can calculate the average like we did in number 16. If we add up these 5 numbers and then divide by 5, we're going to get a number that is most likely the best estimate for the true length of the string. So our answer here is D. Number 18 says the table below gives the lowest temperature in degrees Fahrenheit for 5 different cities last Monday. If the median, we'll come back to that, of the 5 temperatures was 32 degrees Fahrenheit, which of the following could have been the low temperature in Austin last Monday? So median, got to know what that means to get this one right. Median is the middle number. So if you put all the values in order, the median is the middle one. So if I put these numbers in order, 19, 32, X, we don't know where that goes yet, 63, and 57. I didn't put them in order. Let's rewrite that. 57 and then 63. Now they're in order. It's saying that the median is 32. So this is the median, meaning that needs to be the middle number of the list. So if that's the middle number of the list, notice we have two that are bigger. What we need are two that are smaller. So the only answer choice here that's smaller than 32 is going to be 30. And so our answer is choice A here. All right, we've got two last problems here. Number 19 says, the circle graph gives the distribution of colors of markers in a large box. If there are about 3,000 markers in the box, which of the following is closest to the difference between the number of red markers and green markers? So to answer this, we need to know exactly how many red and green markers there are. The way that we can calculate that is by multiplying the percent by the total amount of markers. So if we want the number of red markers, we would do 0.40, that's 40%, times the total, which is 3,000. 40% of 3,000 is 1,200. So there's 1,200 red markers. And then to calculate the number of green markers, we're going to do 20% or 0.2 times 3,000. And let's see what that would be. 0.2 times 3,000 is 600. So this is asking which is closest to the difference between the number of red and green markers. Difference indicates that we want to subtract. So 1,200 minus 600 would be 600. So our answer choice, the correct answer choice is D. Our last question has to do with range. So it's giving us a list of scores and asking for the range. Now the range of a set of values is the maximum value or the largest number minus the minimum value or the smallest number. So as I look at this list, I can identify 113 as my smallest number, and it looks like 321 is my largest number. Now, it just so happens that these are the first and last numbers in the list, but that won't always be the case. These numbers are not necessarily going to be given to you in order. So just be ready to kind of look around in the list and try to find those maximum and minimum values. So as long as you know what range means, this problem's not that hard. You're just going to subtract the largest number minus the smallest number. And so we get 321 minus 113, which is 208. So our answer choice, correct answer is B. And that wraps it up for this practice test. I hope you're getting some good practice. I hope that you are starting to feel more confident with these problems, especially now that you're working similar problems multiple times. I'll make sure to leave a link in the description to the other tests that I've put out there if you'd like a little bit more practice. But as long as you're consistently getting 60% of these questions right, like as you take these practice tests, if you get at least 12 out of the 20 right, if you can do that consistently, you should be able to go into this TSI pretty confident that you're going to be able to come out with a passing grade. So, I wish you all the best of luck. And until next time, y'all have a great day.